Today, we're going to talk about a true giant of the tech world. It's a programming language that runs on literally billions of devices, from huge enterprise servers all the way down to the Android phone in your pocket. And believe it or not, it's been doing this for almost 30 years. Let's dive into Java.
And that's a fantastic question, right? In the tech world, things move so fast. New languages, new frameworks, they pop up and disappear in the blink of an eye. So how on earth has Java managed to stay at the top of the charts for so long? What is its secret sauce? Well, it all boils down to this one single, absolutely revolutionary promise they made right at the beginning. Write once, run anywhere. This idea, this simple phrase, is the key to understanding Java's massive, decades-long success. But what does it actually mean, and how did they pull it off? Okay, so to really get it, we need to pop the hood and take a look at the engine that makes this all possible. Let's see how Java works its magic. The secret ingredient here is something called the Java Virtual Machine, or the JVM for short. Now, the easiest way to think about the JVM is like a universal translator for code. It's this clever piece of software that sits right on top of any operating system. Doesn't matter if it's Windows, a Mac, or Linux, and it's the JVM's job to actually run the Java program. So here's the process. It's actually pretty simple. First, a developer writes their code in Java. Then, a special program called a compiler turns that human-readable code into something called bytecode. Now, this bytecode isn't for a specific computer. It's for the JVM, and that's the genius of it. Any computer in the world that has a JVM installed can understand and run that exact same bytecode. No changes needed. That's platform independence. You'll often hear that Java is an object-oriented language. Now, that sounds complicated, but it just means it's built around the idea of objects, little self-contained bundles of code that have their own data and can perform their own actions. So to really see how this works, let's break down two of the most fundamental building blocks: constructors and methods. First up, we have the constructor. You can think of this like the set of instructions that runs on an assembly line. When you decide to create a new object in your program, the constructor is the code that runs automatically to build it and get it ready. It's that one-time setup that brings the object to life. Now, a method is different. It defines what an object can do after it's been created. It's an action or a behavior. But here's the key. It only happens when you, the programmer, explicitly tell it to. So if the constructor is the assembly line that builds the car, a method is like pressing the gas pedal to make it go. And this table really brings that difference home. Look at the invocation row. Constructors are implicit. The system just runs them for you when an object is born. But methods are explicit. You have to call them by name. This difference between automatically creating something and deliberately telling it what to do is absolutely central to how you build things in Java. Of course, in the real world, things go wrong all the time. Networks drop, files go missing, users type in garbage. Any piece of professional software has to be able to handle these unexpected moments gracefully, and Java has a really powerful safety net built right in for this exact purpose. You know, one of the worst things a programmer can do is just pretend an error never happened. And that's exactly what an empty catch block does. It's code that basically says, okay, I see there was a problem, and I'm going to do absolutely nothing about it. It just silently swallows the error, which is a recipe for disaster and makes the software an absolute nightmare to fix later on. So what's the right way to do it? How do you build those rock-solid, reliable applications? Well, Java provides a really structured solution for this, called the Exception Handling Framework. It's all about anticipating problems and having a clear plan for what to do when they happen. The whole game here is about being deliberate. Use specific types of exceptions for specific kinds of problems. You always log the error with enough detail for someone to figure out what went wrong. And you use something called a finally block. This is a chunk of code that is guaranteed to run no matter what, error or not, to clean up important things like database connections. This kind of discipline is exactly what separates hobby projects from professional-grade software. Now, I know what you might be thinking. A language that's been around since 1995 has to be a bit of a dinosaur, right? Stuck in the past? Well, with Java, that just couldn't be further from the truth. This is not a language that's frozen in time. It is constantly evolving to meet the demands of modern developers. And for proof, you don't have to look any further than the recent release of the Java Development Kit 21. This wasn't some minor update. It introduced a whole suite of powerful, modern features designed to make writing code cleaner, faster, and way more secure. keeping Java right on the cutting edge.
And this slide is a perfect, brilliant illustration of what I'm talking about. Just look at the before code. All those plus signs and quotation marks, it's just clunky and so easy to make a mistake. Now look at the after with the new string templates. It's so much cleaner, more intuitive, and just plain easier to read. It might seem like a small change, but for a developer who does this all day, it makes a huge difference.
And it goes way beyond just making code look nicer. JDK 21 brought in massive technical improvements. Things like virtual threads, which are an absolute game changer for building apps that need to handle thousands or even millions of users at the same time. It also added state-of-the-art security features, proving that Java is incredibly serious about both performance and safety.
This timeline of the major releases really tells the whole story, doesn't it? You can see a clear and even accelerating pattern of innovation. This isn't a language that gets a big update once a decade. It's constantly being improved on a very predictable schedule. And that reliability is exactly why so many huge companies trust it to run their most critical applications.
So let's go back to that original question. How has Java lasted so long? Well, it survived because its core idea, write once, run anywhere, was pure genius. But it thrives today because it never stood still. It adapts, it improves, and it continues to be one of the most powerful and reliable tools a developer can use. Which kind of leaves us with one last big question. After almost 3 decades at the top, is Java's reign just getting started?